beautiful mathematicians. Today we are working on 3.3, proving lines parallel. So on 3.2, I told you had parallel lines, right? So like we have lines and they have those little arrows to tell me they're parallel. Whenever you have parallel lines, then we know, we've got corresponding angles that are congruent, same side that are supplementary, et cetera, et cetera. So today we're working backwards. So if what we used to do was if parallel, then, corresponding angles are congruent. Today we're doing if the corresponding angles are congruent, then the lines are parallel. So we are doing the converse of all of these. If corresponding angles are congruent, then the lines are parallel. If alternate interior angles are congruent, then the lines are parallel. If alternate exterior angles are congruent, then the lines are parallel. So like what we're talking about here is now vertical angles are always congruent, so that one doesn't help me here. But if these corresponding angles are both, 70 degrees, then I know L is, let's see, she did it, 1 and 5. So if 1 and 5 are both, make up something less than 60 degrees, then L is parallel to M. Or interior angles, so if 4 and 6 are congruent, then L and M are parallel. Or if 1 and 7 are congruent, then L and M are parallel, right? So you are working backwards to prove these lines parallel. Similarly, we can do the same thing if these same sides are supplementary. So if 6 and 7 add up to 180, then they're parallel. If 1 and 8 add up to 180, then our lines are parallel. So we are just working backwards here to prove the lines parallel. Determine whether L is parallel to M based on the information. If yes, state the converse that proves it. All right, so these two are congruent. Those are alternate exterior angles. So yes, M is parallel to L, and that's the converse of alternate exterior. All right, now I have these two are going to be corresponding, and there's one tick mark, which means they are congruent. So yes, M is parallel to L, converse of corresponding. All right, these are vertical angles. Vertical angles are always going to be congruent, no matter, it doesn't have anything to do with L up in here. So no, we cannot determine that these are parallel. Maybe they are, but we cannot prove it given what we've been given here. And then last but not least, same side, are they supplementary? 125 plus 65, yeah. Ooh, that's 190. So no, they're very close to supplementary, but these are not parallel lines. Nope. Those would have to be supplementary in order to prove that these are parallel. So actually, that's enough to say no, not parallel. Right? Because they'd have to be parallel. They'd have to add up to 180. Determine which lines, if any, are parallel. State the reason that justifies your answer. So y'all, these are like kind of one-step proofs here. So 4 and 2, if those two are congruent, they are corresponding. Now they're cut by the transversal A, and so the parallel lines would be C and D. C is parallel to D. It's the converse of corresponding angles. All right, now I've got 5 and 10. 5 and 10 are congruent. Okay, those are alternate interior, and they're inside A and B. So that means for these, A is parallel to B. Converse of alternate interior. Nine and 13 are supplementary. 9 and 13 are supplementary. Nope, that doesn't help me any. Those are linear pairs, so doesn't do anything for me here. Can't prove things are parallel with a linear pair. Okay, 1 congruent to 14. 1 and 14. So I have 1 here. I have 14 here. All right, so those are going to be alternate exterior, and they're exterior of A and B. So that's A parallel to B. Converse of alternate exterior. 14 and 15 are supplementary. 14, 15, 14, 15. Supplementary. So that same side, interior of C and D. C is parallel to D. And that is because it is the converse of same side interior. Alrighty, choose a different color. 11 and 16 are vertical angles. That doesn't help me any. 1 and 13 being supplementary. I'm redoing my colors, y'all, sorry. So let's see, let's choose a red. 1 and 13, 1 and 13 are supplementary. So that's same side exterior of A and B. Converse of same side exterior. All right, keep going, keep going, keep going. 2 and 7, 2 and 7 are alternate interior of C and D. C, D. Oh, converse. And then where are we at? 6 and 11. 6 and 11 have no relationship. If those two are equal, yeah, I don't think those catty corner things don't help me at all, really. Because 6 probably means that actually all of them are going to end up being, I'm going to say none. But truly, if you go from 6 to 14, those would be corresponding, right? So if 14 is equal, then if 16 is equal, and then 11 is equal, right? But that's a lot of ifs and thens, so that's why we're going to go for a none there as opposed to both sets being parallel, because I think that's what it ends up being. All right, which lines or segments are parallel? Justify your answer. Okay, I got to do a lot of coloring here. So I have 40 and 40. So let's see. The transversal that they're going to cross is going to be this thing. They both touch that. And then they both have, okay, 40 and 40 are both going to touch these guys. So that means AB is parallel. AB is parallel to CD. But y'all, then there's another set here. I've got these are congruent. They touch the same transversal, but now it's talking about these parallel lines. So that is BC parallel to DE. Both of those are true. Let's see, that's all going to be corresponding. Converse of corresponding. All right. I got these guys. Okay, the transversal they touch is this one. They both touch that line. So the parallel lines, those are going to be alternate exterior, and they're exterior of Q and S. So Q is parallel to S, and that's converse of alternate exterior. Whew. This picture is crazy. 8, 5. All right. They both touch this guy. I'm going to ignore this B on the inside. So I'm going to redraw this here. I've got A and C. So 5 is right there and 8 is right there. Let me get this out of the way here. Let's see what I've drawn here. I've got D, A, and C. I just ignored. I'm ignoring the B. So those are alternate interior, which means that A is going to be parallel to C. Converse of alternate interior. Whew, lots happening. Lots happening. Okay, find the value of the variable that would make the lines parallel. So we are saying that A is going to be parallel to B if these two are congruent to each other because they are corresponding angles. So we're going to say 9x plus 11 equals 74. So minus 11 on both sides, 9x equals 64, 63. So x equals 7. So if x equals 7, then A and B are parallel by the converse of corresponding angles theorem. Lots of words there. You got it. All right. These two are on the same side. So A and B, we're going to assume are parallel. A and B are going to be parallel if these two add up to 180. So x plus 72 plus 65 equals 180 degrees. X, I'm lazy, where's my calc? 72 plus 65 is 137 equals 180. 180 minus 137 is 43. So if x equals 43, then A and B are parallel by the converse of same side interior angles theorem. Whew. Now these are going to be alternate interior if L and M are parallel. So they're going to be congruent if L and M are parallel. So I'm going to minus 6x on both sides, 4 equals 2x minus 8, plus 8 on both sides, 12 equals 2x, divide by x equals 6. So if x equals 6, then L and M are parallel by the converse of alternate interior angles theorem. You see what we got going here? Rock on. Your homework looks very, very similar to the notes we just did. You're going to do great. Best of luck.